I'm Jarno Vehmas, and today I'm going to show you a presentation about how to use printed electronics. So when the title is like everything in 10 minutes, it's about to focus some fields, and it's really like Tommy said that I'm going to present more about my personal experience in this field, but also the technology what we're offering as an ecosystem. I love the way Brett was explaining what are the key features in this system that we are building now, and really I call it also as a revolution of printed electronics. So in the presentation, I'm going to go first quickly through what is the printed electronics, and then going more deeply what is printed electrochromics. We're going to look some of the samples what we have done together with these our partners, and then hopefully in the end I have some time still to wrap up the questions, and also especially the answers will be after Jani Mikael's part. So won't change the title. No, right. So like Brett was actually showing, the printed electronics has been there for years. It's been already in the 90s, and mobile phones, especially in Finland, was some of the pioneers using these technologies. But mainly it was just like interconnections, flexible circuit board, etc. So here, what I mean for the printed electronics is using the functional materials, which are mainly in the form of inks, so that we can utilize conventional printing machines, which are widely available. And that is really the beauty of this printed electronics. And printed electrochromics fits perfectly to this world. So when going to look printed electronics as a structure, it's more like what Andrew was showing. They are quite often the pictures and presentations, visualizations look very fancy and very complex, but in fact, most of the components still are pretty simple, and they have this type of structure that you have some conductors, and then you have a multi-layer area where the actual magic is happening. And it doesn't matter if it's like a OPV, like a solar cell or sensor, or a printed capacitor or something. They have some similar functions on each of them. This is like one of the disclaimers I'm going to say, that here I know that there are a lot of people from other field of businesses, not from electrochemical field or electronics. So for some reason, somebody when doing electrochromics must be love a lot of the word electro. We are focusing and following mainly the electrolyte and using electrode word. So the simplest form of electrochromic device looks like this. It has two printed areas using or based on electrochromic ink. We call these as electrodes. Typically, other one of them is the one which is getting the color, and the other one will be then behaving as the counter electrode. Top of these we have electrolyte, which enables this. And look, especially on the left, the electrolyte is not covering the entire printing. So when you apply power to the system, what happens, the part, and only the part which is in contact with the electrolyte area, will get oxidized and will get colored. And the other part will be getting more transparent. So this is the typical system. I can rewind that again. This is the typical system with a typical electrochromic materials and the electrolyte what we are using. And then continuing the same structure as the previous one, where the pools are side by side, but you can add easily more segments on it. So you can have several segments, but use still the same counter electrode for all of these active segments. Quite often we hide. So here the pool is where we have the dark blue and not the light blue. So this is only where the electrolyte is located. So if you look these areas, you can see that there is some default, like a default in the design, in that sense that if you activate all the segments, the counter electrode is too small. This type of issues you have to deal with when doing electrochromic designs, but everything is pretty simple. Another version, which is maybe the most common one and most versatile in design sense, is the vertical structure, where everything is like in the form of particularly like a sandwich, vertical stack. You have the bottom layer where you have one electrochromic materials graphic, then you have an electrolyte, and then you have this type of adhesive frame. There's a hole in the middle, and that is filled with the electrolyte. And then this is also like creating the actual display. It's glues when you laminate it because it has that double feature on it. And then you have just a similar layer in the top, and you have a different graphics. So then you can switch between these graphics. This is a real prototype what we have done together with Epishine. And here you can see the display in the middle, close to the soil. So this is a moisture sensor device that you could use in a garden or in an inside house. And all the power is harvested using the printed organic photovoltaic or solar cell, more familiar name for that. That is done by Epishine, a Swedish company, and we provide that display part to this one. So all these power needed to do the measuring is harvested on this OPV panel and then stored inside the electronics. And then based on the soil, then the moisture in the soil, it shows either happy or sad face. So far, all these displays and the samples what I have been showing, you can do and utilize those using our materials, what we have on the ink kit. So we have there all the inks, including silver electrolyte, electrochromic ink. We have other variety of PAT with coating and without coating, and then also the material for the electrolyte pool. We have also instructions and videos available for that. The vertical structure, we can go a little bit further on that. So these here are using a different polymers. These inks are different. So we are using here blue and magenta colors. On the left, this is already like a more complex design. It's quite a precise, and especially when you had to deal the overlapping of these small letters. So there is not much room for like offsetting these when building the stack. Also on the right hand, we can see already a display which you can find from our temperature threshold sensor label. This one is roll-to-roll printed in Sweden. So difference between this one and what I was showing earlier, the main thing is two components that we are using, especially electrolyte is non-transparent, it's white, and that allows us to use the carbon as a counter electrode. Again, this is more just for reason to go into the high volume production, and the functions are pretty same still. Then you have seen in some of the our presentations, and also that we have a other type of completely differently behaving electrochromic material. Irreversible can be activated only once compared to this normal electrochromic material, which can be cycled like 100,000 times or even beyond that to millions. On the middle, you can see also this label. The design is from the impact label. The display itself and the symbol which will be activated is in the middle, and the outer ring is for the activation lid. So you can have easily multiple functions to the same label. And then back to the powering issues. So typically we need very minimum volumes of current, and also the voltage are mild 1.5 to 3 volts, which fits very well to this world where you have a coin cells or NFCs or OPVs available. So our one, if there is like always which comes the questions with the electronic designers is that how we should drive this display. So the display is really comparable to a capacitor, printed capacitor. So this means that you have to drive it same way. There is a small peak current in it, and then it also stores energy. So once you have the full capacity inside the display, it might also flow backwards to your driving units. But again, those are things when you're trying to make it to the maximum. So in case you just want to show the device and how it functions, the coin cell is really easy. We have the coin cells on most of the samples we have. We have also there like a simple timer. So when you press, it does something, basically switch polarity or other type of things. We have also shown already the NFC chip as a power unit and an organic photovoltaic. Unfortunately, there was not samples of this one yet, but it will be revealed in the next week. Jan and Mikael will tell more about that. And one great thing, what I would like to really highlight that as design in electrochromics, it's more than just making fancy graphics on a 2D form. It's something between that and three-dimensional as you have the animations, you have the timings and pulsing. So this AirDot kit, it enables really easy to go on the Arduino world and start to do prototyping and really nice stuff on utilizing these type of technologies. And this is really close what Brett was explaining also earlier. So then to the summary. In fact, I would copy exactly what Brett was saying earlier. I also believe that we are really seeing a revolution in printed electronics. And earlier, when I start my career in this and exploring these printed electronics materials, we had like issues that the materials were pretty crap. We made something which was functional for a couple of hours, and nowadays we have a very, very wide possibilities to use like barriers and other type of more developed material, the polymers and everything. So also the printing has come further. So I really do believe that we are facing the revolution of printed electronics and printed electrochromics. So thank you.